Number 11 says, by inspection, determine which one of the following equations will have an extraneous root and explain your reasoning. So the basic principle we're going to use is the fact that the square root cannot equal a negative number. Okay, so principal square root is always defined as a positive value. So this is not possible. Okay, and we end up getting solutions because when we square to undo the square root, there's not a perfect match of the opposites of squares and square roots. So when we square this side, we end up with an x and we get a squared. Okay, so this mismatch here of the square and square root generates this possible solution. So we end up with a solution that actually doesn't exist. So what we're going to look for then is we're going to look for the square root equaling negative. So I'm not really even concerned with the inside. I know that 3y minus 1. If I isolate the square root, I end up with 7, and that's perfectly possible. For the second one here, we're going to do the same. I'm going to put the square root on the right hand side, and then I'm going to add 9 to both sides. I end up with the square root equaling positive 13, and again that's perfectly okay. For the last one here, I'm going to isolate the square root, and again we don't really care what's inside the square root. We're going to subtract 9 from both sides. We get square root equals negative 7. Well, this is not possible, so this last solution here is going to give us an extraneous solution. So this is going to give us an extraneous solution.